good morning again. So I'm Stephen Cleary. This is Asynchronous TCP IP chat application part 4. Big shout out to my GitHub sponsors. Somehow I've been forgetting to say that. They really encourage me to do this kind of thing. Just the fact that somebody is actually sponsoring me. So last time we ended on something wasn't working right, and I couldn't figure it out, but I had to get to work. So I hate leaving things in a state like that. So anyway, after work I took a look, and it wasn't that hard to find. There were actually a couple of bugs in the code. So I'm going to go ahead and start off with those. We're going to fix those bugs, and then we're going to start a bit of a refactoring that happens pretty commonly when you're doing both a client and a server like this. The code as it currently is the client code is all essentially in one file. The server code is all essentially in one file. And it's getting long enough to where that really needs to be split out into separate types and into a separate library, actually. But anyway, the bug fixes first. Let's do that. So let's come on over here to my computer. And this is our parsing code. So this is on the server side right now. Later today we'll be merging this with the client code and putting them both on client and server. So right now we're on the server side. We're looking at our message parsing. This is reading the messages out of the pipeline. We've got the socket copying. We've got the thing that's copying the data from the socket into the pipeline. That's this code right here in the socket to pipeline async. And now we're looking at the parsing. So there were a couple of bugs, and I won't walk through the details there. I actually had to. I was actually down into the pipeline source code, which is open source, so you can actually find that online. If you do a pipe reader, for example, see it autofills for me because I was doing this yesterday. The one bad thing about a GitHub search is it always finds the test first, because that mentions the type more than the actual type definition does. But usually it's not too far down. Here's our pipe reader right here. So you can actually look into the actual source code. Although the source code I found the result of the bug was actually not in the pipe reader. It was in, where was it? Let's see, it was actually in the sequence reader, right? So not looking at the pipeline code, that's fine. The sequence reader type has I'm going to say a questionable API design decision at this point. That one of the bugs I found was totally my fault, 100%. The other bug was I think a questionable API, and that's this line right here, this try copy to. So it's not really a questionable API decision, it's a questionable naming thing. Okay, that's more of the question. Because here this try read big endian and all these other, try to read this type, try to read that type out of the sequence reader, what they do is if they're successful, then they advance the sequence reader position. So you've got, so if this is successful, then whatever position the sequence reader is at, it moves forward 4 bytes, the size of this int here. That's not the case with try copy to. Try copy to says, well, I'm going to wait until that many messages are, or I'm going to, if that many bytes are available, then I'm going to copy them out. But I'm not going to advance it at all. I think the idea behind this was, well, I just want to copy this out into a byte array or whatever and do some manual parsing. And then I will advance the sequence reader and I might not take all the data. I think that's the idea behind this, the reason this API was done this way. I think it could have been named better, like try copy to without advance or something like that, to really call that out, because this one acts completely differently than all the other parsing methods on this type. But it is what it is. So I'm just gonna, so the fix for this is to just advance it by hand. And that is, so if it's successful, So this is the not successful branch here. But if it is successful, then what I want to do is say sequence reader dot advance, and then we're going to advance it by the number of bytes that we read out in the chat message. So this will be length prefix -4. Or actually, just to make this a little more explicit, this is the number of bytes that we actually read, which is the same as the length of the array. And I'm just going to stick in a little comment here. Unlike other sequence reader methods, try copy to does not advance the position. Little FYI, that's why we're doing that here. Let's see. So the other bug that I had, actually, let's go ahead and demonstrate this with the way that we have it now. It does have a bug. So what I want to do is walk through it. Let's go ahead and build this and run the chat server. And then I'm going to have to run the client separately. I'm just going to do a separate window for that. Let's jump into TCP chat, and ChatClient. And then, oops, I do want bin. Thank you. Debug. Yes. So now we can do our TcpClient. That did not work. ChatClient. All right. So now when I connect here, I'm gonna break into this this code as soon as I hit connect. So so first we're gonna try to read the length prefix, right? And that should succeed. And we have a length prefix of 18, which, sure, that's about a hello server message. We've got our message type that we're reading next, which should be 0, and it is 0. Okay, so we're going to step in here, read out the chat message bytes. So these are the bytes for the actual chat message. The copy was successful, and we can see here this looks like ASCII data, sure. And then we're going to advance the sequence reader, and we're also going to tell the pipe reader, okay, we have read this complete message, so go ahead and advance to where our sequence reader is. And then we decode the message, stick it onto our result, and that is in fact correct, hello server, all right. And then now we're going to observe the other bug that was in this code. And that is that it immediately tries to read the next sequence reader. That fails because there's no next message yet. And then this is the bug here, where we're actually we're trying to advance the pipe reader back to the beginning of the buffer, which does not work. It throws an exception. So let's go ahead and fix that. This one should be a pretty simple fix where we can just say, while the sequence reader still has more data to process. So now we can actually read from, let's build this and try it out. Now we're going to run this server. I'm just going to use the same client, it doesn't care. And there, now we got this chat message. So at this point, we are not just sending bytes down the wire anymore, right? We've gone from that, which was the initial, first couple days. Now we have an actual protocol being used. We have our messages being delimited. We have a message type on our messages. So now we are actually starting to use a protocol. We've got and we've got that message actually working. So, good so far. Now the next thing that I want to do is, actually, you know what? What I really want to do. because what this advanced to here, instead of buffer start, we actually don't want to pass buffer start here, do we? This should be sequence reader.position. Yeah. And the reason for that is we don't want to ever like try to rewind the pipe reader. That would cause an exception. So if we get one message and then a partial message, this code won't work. So let's replace all of these with that. And that's not going to work either. Okay, I have to think this through. Sorry. I should not have tried using pipelines. I apologize. This is more awkward than I expected. So in order to read this, well, this one would actually work with a... Oh, you know what we actually need to do? So I'm going to take this advanced to, and I'm going to move it out over here. Because after we read any kind of message, we want to advance it to where our position is. So when we're coming in here, the problem is this buffer start can still be a rewind if we've already read one. And we don't want to do that. I'm just trying to think of the appropriate math here for this. So our sequence, so this could be a sequence reader.position. You know what I'm going to do? I'm going to say right here, I'm going to say begin of message. Okay. Position is right where our sequence reader is right now. Yes. I think I can do this. I'm not actually 100% sure. Because positions have this limitation on their usage. And I'm not sure if I can actually take a sequence reader position and pass it to a pipe reader. Well, this code actually worked. So I must be able to do that. Okay. So I've got this begin of message position. So in other words, the pipe reader is always going to, this call to advance to, this first one is actually saying don't move. We don't want to consume any part of this message, this next message. But I have observed all of the data that you've given me and it's not enough. That's the logic behind this pipe reader.advance to. Okay. So I think that I've fixed all the bugs there. Let's just run this again to be sure. Make sure that I'm still getting that message across, and we are. Excellent. All right. So at this point, actually, I'm going to go ahead and commit this. Bug fixes for day 3. And now at this point, what we have is a pipe reader on one side, on the server side. And we've got a pipe writer on the client side. All our messages are just going one way, right? But we're going to want bidirectional messages very shortly here. So what I'm going to do is I'm going to extract the reader code and the writer code out of their separate processes. I'm going to combine them into a library. And what we're going to do is we're going to have a single, like a connected chat client type. And the reason that I'm doing that is because in this, in my socket frequently asked questions here, under the connected sockets, so here's how you use a connected socket, and I talk about a lot of things, how writing works, how reading works, error detection, which we haven't covered yet in this series, but we're definitely going to. Okay, so I guess it's right up at the top here. So what we're going to do is treat this as a connected socket doesn't actually care if it's on the server side or if it's on the client side. Once it's connected, a TCP/IP socket is exactly the same on both sides. So we're going to actually, use that in our code and define like some kind of a connected socket type. So I'm going to add a library here and say this is going to be, yes, that's right. And this is going to be my chat. I don't know if API is quite the right word. I'm going to call it chat socket. No, I'm going to call it my chat. Yeah, chat API, sure. All right. That's fine. And then I'm going to have a new class, and this is going to be my ChatConnection. Okay. My classes are always sealed by default. That should be the default. And I'm definitely going to need a socket. Oh, come on. That was not as much helpful code completion there. And actually what I'm going to do is I'm going to stick this on a property called socket. All right. And the reason, so usually when I write types like this, I always expose the underlying socket because there's certain scenarios that you just, people want to use it, want to set certain settings or whatever, like, oh, I want a larger receive buffer because I know I'm streaming video to me, or I want to turn off the Nagel algorithm, or some like weird thing that they want to do that they have to have access to the underlying socket for. There's 100 different socket options that people can set. So you don't want to like include all that in your API. You just want to say, fine, here's your socket, do whatever you want with it. But please don't close it, or something like that. It's kind of implied. Please don't close the socket I'm using. All right. Public Boolean is connected. No, I'm definitely not adding that type, or that member. So we've got, just got to rename this here. So we've got a ChatConnection type now. And what I'm going to do is I'm going to move our pipeline code from the client into this and from the server into this. And then we're going to use this type from both the client and the server. That's the idea here. So we've got this, this code here. Let's do the writing first. That's fine. So, so just a quick word here on the streams. As a reminder, TCP/IP sockets have a stream abstraction, not a message abstraction. So we're dealing with a stream of bytes. And what we actually have is, let's talk about writing. Well, let's talk about the pipe all the way through. Okay. So, so on the client side, the client's going to send a message to the server. On the client side, we're going to bundle that up into a pipeline pipe, and then that gets written out to the socket. Now the socket write actually has like a buffer. There's a write buffer in the OS for that socket. So that write goes into the OS buffer, and then the OS sends from its outgoing buffer into the remote machine's incoming buffer. There's also a buffer for input over here. And then we're going to be reading that out of the socket and into another pipeline on our side. So that's the pipeline all the way through, just going one direction. There's also a pipeline, or there's also a connection going the other way. Okay, so each socket connection is actually two streams. There's an outgoing stream and an incoming stream. Now sometimes these are represented as a single stream type, notably the NetworkStream, right? The NetworkStream type in .NET is actually conceptually two streams. It's a write stream and a read stream, and those are actually independent of each other. So it's very different than like memory stream, right? Memory stream is a read-write stream, but there's just so memory stream is a read-write stream. Sorry, I had a little lag there. Memory stream is a read-write stream, but you can't read and write at the same time, right? Those are not independent. You have to write to it, then rewind it, and then read it. There's only one stream position. NetworkStream is very different. In a NetworkStream, you can read and write independently, and position has no meaning in a NetworkStream. There's not a single position. You could say there's like a position for writing and a position for reading, but that's not really a helpful idea. So anyway, just to make that clear, we're talking about two different streams. So when we're writing our ChatConnection type here, I'm going to actually have two separate pipelines. I'm going to have one just for reading from the socket and the other one just for writing to the socket. And those are not going to be connected in any way. I think that the pipelines actually has a concept for that, an iDuplex pipe. I don't know of anything that actually uses iDuplex pipe at the moment, so I'm not planning to actually make use of that interface, but conceptually that is what we're doing with this chat connection. So okay, so let's just copy this thing and see what. So the first thing we need is we've got this pipe. Here we go. We need a pipe for writing. So I'm going to say now writing and reading. That I'm just trying to decide on my terminology here, because when you're reading a type like this, terminology is important. So I'm going to say that actually do I want output and input, or do I want read and write? And I think I want output and input, because this type will have to read and write from and to the output pipe, and it will have to read and write from and to the input pipe. So just to kind of ensure, I think the code will end up being clearer if I name this input and output pipe. So we're going to have a private pipe. Of course, I don't have the NuGet package. That would help. So let's hit pipelines. Yes. Oops. So we've got a pipe for an output pipe. And we're going to do the same thing for an input pipe. So this is data going out the socket, data coming in the socket. Two separate connections here. So let's do, of course, output pipe. Now, very shortly, I'm going to want to allow the creators to pass in pipe options, but we're for the creation of the pipes, but I'm not going to do that right now. Right now, we're just going to create basic old pipes, and then what I want to do is have, what am I working on, the client here? Yes. So I'm going to want to, start off this pipeline to socket type class here, and I'm just going to copy this wholesale. So this is our code that's copying from the pipe reader into a socket. So this is our output pipe going into the socket. What I want to do here, and I'm just going to discard this for now. We will clean this up later. So this is going to be the output pipe, pipe reader. Yes. The idea being, yeah. So this is the output pipe is data that's going out. So this type reads from the output pipe and writes it to the socket. Yes. And then we also want to, We also want to expose the pipe writer. Okay. This is going to be our I'm just going to call it the output pipe, even though that's not. Yeah, kind of reusing that name there. So this will give the users of this type a way to write bytes to the socket. And yeah, so that should be that. And then the other thing that I need is from our server over here. I'm going to kind of do the same thing. I've already got the pipe written here. Yeah. So I've already got the pipe written here, and I'm going to steal this code right here. That'll just be private. And this one's reading from the socket and writing to the pipe writer. So let's start that off here. Now we're going to read from the socket. I like the order of the arguments here. We're reading from the output pipe, sending it to the socket. We're reading from the socket and sending it to the input pipe. I like how that ended up. All right. That's a problem here. More than one protection modifier. Oh. So then we also expose this pipe reader. So this is the kind of type that it's useful to actually write down a little diagram of, hey, here's this pipe and here's how things are connected, because it can get a little confusing. I've tried to clear it up with the terms output and input, but yeah, I think I have it right. We'll see. Let's see. So that all looks good. We do have some things in here like this, handling the completion. You know, up here, I'm just thinking about like API symmetry here. So up here we have, when the socket has been closed, then we complete the pipe writer. That makes sense. We complete that pipeline. And over here, when the pipeline is completed, we should probably close the socket. So I'm just going to go ahead and do that. And that should initiate a graceful closure on that socket. All right. There are other things we're going to want to do when that happens, but we'll cross that bridge when we come to it. Okay. So I'm just going to expose this here too. So now here's something that I'm never really sure what to name. So we've got like two different loops going on here. Now every socket is being read from and it's being written to asynchronously. Now, what do we want to call that runner code? Right? It's like a loop for this type. It's like a main loop. Sure. So I'll just call it main task. And what we're going to do is toss this into here. Just to get rid of these discards right away. Because what I think we want to do is wrap this into another type almost right away. So we got rid of that discard. Fine. Let's clean that up a little bit. All right. So now we've got like this ChatConnection type that is a socket plus a pipeline. And actually, this doesn't have anything to do with chat yet, does it? No, there's nothing chat specific in here. This is all very generic. I wrapped a socket in a pipeline code. So let's change the name of this type into, it's now a pipeline socket. All right. Now let's change our server and client to use this type, make sure everything's still working. So coming over here, well, let's go ahead and get rid of this, because this type, or this, is no longer necessary. Our pipe is no longer necessary. Instead, what we want is a pipeline socket. Of course, I'm not referencing that project. So right now all it needs is that connected socket, which is our client socket on the client. And then all of this is still like our chat specific stuff. We don't have a pipe here anymore, or a pipe writer, but we do have that hanging off of our pipeline socket type. This is going to be our output pipe. And let's just go ahead and say we advance that in here and we flush. That should work. Let's do the same thing to our server. Gonna add our chat API over here. And we're gonna remove all of this code. Now all of the parsing code, so all of the, on the client side, here's how we build a chat message for our chat API, or our chat protocol. This logic is still not covered by this type. And in the server side, the same thing. Our parse messages is still going to be like outside of that type. So, but what we can get rid of is making a pipe. We can get rid of this socket to pipeline. What we do is create a new, I added a reference to that, all right. Create a new pipeline socket. And we are going to pass in our connected socket, which in this case is like the new one returned from accept. I said it right this time, not listen, accept. When we get the new client socket, or a connected socket from accept, that's the one that we pass in to this method here. So we've got this, so we've got a pipeline socket now, which gives us a reader for the input pipe, reading from the socket. So this pipeline socket dot input pipe, yes. And actually we don't, well, actually I guess we could take the pipeline socket dot main task into here to tie that in. Okay, so then we have, this will still read from the pipe reader, and all the parsing is still done outside of that type for now. Let's go ahead and build this, and let's see if it works. All right. So I'm just going to go ahead and run the server here, just like we did before in the debugger, and run the client outside. And when we connect, bing, there we go. All right. So we've got we've extracted out all the code that just deals with wrapping a socket in a pipeline. All right. And that's been, I don't know if it's really been worth it to do that in this series, this video series. Looking back, maybe I should have just done it with raw sockets. But essentially what we have ending up here is similar to an abstraction that's already in the BCL. So this pipeline socket here is essentially a TCP client. Okay. We looked at the socket type before. We've looked through all these methods a few times in this video series. This is the socket type is the Berkeley API. This is the very the very portable kind of API here. There is another socket API in .NET, and this is the one that I don't know if I would say most people use. It really depends. But this TcpClient and TCP listener types are like the next level up. This is essentially what we wrote for socket, reading and writing from pipelines. That's what these types essentially do, but with streams. So you have a TCP listener, which is just a nice way of saying, I'm listening on a socket. It's just a simpler API. This socket API is really overwhelming, and you can call like accept on a socket that is intended to be used as a client socket. Nothing stops you from doing that. So this TCP listener API is a little easier to use, and you can even say accept TCP client, which gives you back a TCP client, and a TCP client is a connected socket. This is the BCL equivalent to what we wrote here, this pipeline socket. Okay, pipeline socket and TCP client type are logically very, very similar, except ours uses pipelines and the BCL one uses streams. So you've got this like network stream that you can get from the client, and then you can read and write to the network stream. So this is logically very similar to what we ended up building here. If you want to use streams, there's nothing wrong with that, especially with regular TCP/IP applications. Usually you don't need the more performant pipelines. You can just get away with using streams. I've already got into pipelines, and the reason that I chose pipelines for this project is that your parsing code is easier. So this code down here, which is the most complicated code we've written so far, is actually a lot easier than it would be. I don't know if it's a lot easier. It's definitely easier than what it would be using streams. But I might have to revisit that. Okay, so we got a question about, or from the chat here. If you know there's a dedicated reader pipe with disparate to bar stream equals new network stream socket, yes. Bar output pipe equals pipe reader.create stream. So yes, Cecil, you can absolutely do that. So what he's talking about is you can create a network stream that just wraps a socket. You can literally pass the socket class to network stream because that's what it's made for. And then that gives you a read-write stream. And then you can create a pipeline wrapper around the network stream. Now, that's a good point, because that way you can end up, it would be easier. We would actually be able to get rid of pretty much this whole pipeline socket type with the reads and the writes if we did it that way. And then because we're wrapping the network stream in a pipeline, we would also get the easier parsing. So that's actually a great idea. I do like that. And should we do that? Throw all this code away. Yeah, that might be actually a lot easier. So that way, instead of reading and writing directly from the pipe reader or directly from the pipelines to and from the socket, we would be going indirectly through a network stream class. It would add one more buffer, right? But it's certainly doable. I'm going to leave the code as is for now, but that is definitely an approach worth mentioning. So let's see. What I want to do at this point, we've gotten our pipeline socket, out of our main code. Commit this code before throwing it out. Yeah, actually, I should probably commit this code anyway. So this is day 4, partial, extract pipeline socket. This is a very good point at which to commit. now I want to, so right now our client is still only writing and our server is still only reading. And what you really want to do on both sides, well, I mean, they have pipelines connected now, so technically our client is also reading, but it's just reading into a pipeline that no one else is reading from upstream. So what we really want to do is have both sides reading and writing all the time. Well, both sides reading all the time at least. Only write when they have messages to send. So right now we only have a one-way message. We've got the client saying, hey, here's my chat message, and the server accepting whatever messages. Well, we also want to be able to send messages from the server to the client, like, hey, someone else chatted something, right? So, so our chat client is definitely going to have to start reading and parsing messages using our protocol. Since both sides are parsing, which is, again, extremely common in TCP/IP protocols, both sides end up processing or parsing messages. Since that is going to be shared now, my goal here is to move this parse messages out of this chat server application and into my actual chat API. So I'm going to add a new type for this, and this will be an actual chat, like a chat socket. Okay. Let's do this, and I'm going to think about what kind of API I want on this. What I want to do is have the ability to write messages. And at this is the point at which I actually want to define message types, like as actual C# types. Because I want to write messages. And then I want to be able to write messages to the socket, and I want to have like a stream of incoming messages. And I'm kind of thinking you can do that through, let's do it through an async enumerable. I like that idea. And there's a little trick that we can use to make that so we don't have to build one from scratch. Essentially, just use a channel. System threading channels gives you like a buffer. It's essentially equivalent to a TPL data flow buffer block. Or you can think of it as like an asynchronous producer-consumer collection, or an asynchronous queue. So we could use a channel, and then that implicitly just uses an async enumerable. I like that. We will have to be careful about our error handling, but I think that would work very well, actually. Okay. Error handling is coming up. It is going to be interesting. All right, so for now, let's just move that parsing code into this chat socket. Now the chat socket is going to be built on top of our pipeline socket. So let's go ahead and get this thing going. Do we want to expose the actual pipeline? I do not. What I want is, I do need to expose the socket still. Okay, didn't work either. Oh, there. Sometimes IntelliSense really helps, and sometimes it's just not, not helpful. This should Oh, right. Okay. So now we can pass that socket through so that people just using ChatSocket can also directly access the underlying socket, set any options or whatever that they need. So let's see, what next? What I want to expose is an async enumerable of messages. And we don't actually have a message type yet. Maybe we should do that first. So let's see here. I'm just going to do definitely like an iMessage, iChatMessage. Well, I'm just going to call it iMessage, with the chat message being one specific kind of message. Now we're going to eventually want some members on this type, maybe around parsing. Yeah, parsing and like serializing in and out, essentially. But in the meantime, let's do a chat message here. So, what this chat message carries right now is just the actual, message. Message is way overloaded here. I'm just going to call this text instead. Okay. I wonder if records would be more appropriate here. I think they would be. But just to keep it simple, I'm just going to do the I'm just going to do it like that. All right. So we've got chat message, chat socket, and I'm gonna go ahead and we'll do the constructor here, and this is looking more and more like a record type. Fine. All right. So we've got our chat message that we're gonna actually parse out. That's the only one we have currently defined in our protocol. So let's come back up here to our chat socket. And what we want to expose is an async enumerable of IMessage. We want this as like a method or property. Just make it a property. That'll be fine. Let's wait and hook that up until after we have everything else. So what we really want to do is take this parsing code out. Let's figure out how that's going to hook in first. And actually, let's, let's just take this whole thing first and then we'll change it around. So we've got this parsing code. Yeah. Just thinking about how we're going to serialize back and forth. I think this makes sense. Okay. And this is called, actually what we're going to do is we're also going to take where this is called from, because this is like the main loop that we need to handle here now. So this thing has its own kind of main loop that it's going to be running for reading from the pipeline in this case. Let's bring this into scope. Okay, so we'll change this up in a little bit. We're not going to hook that up quite yet. All right. So what we want to do then, we also want to expose our own, like a main task. Although, in this case, because we will be exposing the async enumerable, so we might not actually need the main task. But let's see. Let's this in the constructor. So this is going to be the combination of the PipelineSocket's main task, and we're also going to call this handle pipeline async. And pass in the PipelineSockets. Actually, yeah, we can just change this to be local variables. This will never change. So our pipe reader becomes the PipelineSocket dot input pipe. Okay, so we're reading from that. And again, this doesn't actually need to pass the pipe reader here, because this becomes a local type. I can type. All right. The only other thing that we're missing here is the max message size, which we can actually pass in as a property on this type if we want to. Yeah, let's do that. Okay. So instead of defining this out here, we're just going to define it as like a optional argument here. So now we've got our max message size here, which is now a local variable. All right. Not local, it's a class variable. All right. So now we've copied all that code out of the server, and now we have a way to read messages, and this just dumps them to the console. We also need a way to write messages. So we're reflecting this API back, and right now this is only done in the client, and it's all very hard-coded. We're going to make this a little bit more flexible as we copy it over. So I'm hoping that I get through the chat socket today. So let's say write message. This is going to be an iMessage. It can be any message. Oh, you know what? Actually, before we do that, sorry. What we really should be doing here, instead of returning a string, which assumes this is just chat messages, I want to make this into an iMessage here. Use our new abstraction. So our result is a new iMessage. And then, all right, if our message type is 0, then we're going to add a new chat message. And our text is the decoded chat message bytes. Yes. All right. So now instead of parsing this out into a list of strings, now we're parsing it out into a list of message types, or message classes, one of which, only one exists now, which is chat message. We'll be adding some others in a little bit. Okay, so now we got this message, blah, blah, blah. We actually have to pull the text out because, right. So let's say here. Now we have to distinguish between what our different messages are. So message is chat message. Then we can actually write out, hey, we got this message. Chat message.text, the actual text of the chat message. And I'm just going to add in here unknown message. All right. So now this is our server here, and we can handle parsing and retrieving messages using this more arbitrary or more flexible iMessage interface. Now we want to add the ability to write a message. Let's say send a message. And this is an IMessage. Now, I guess the, so if you really want, well, I'm trying to decide if I want to do parsing and serialization, as part of the iMessage interface, and I'm kind of actually thinking maybe not. We could leave the iMessage just as a marker interface. It's an interface that has no members. You just add the interface to say, this is a message type. So there's advantages and disadvantages to both. The advantage to keeping it out of the iMessage type is that your different message, all your serialization code is like right here in this type. This chat socket then defines, here's how all your messages are parsed and serialized out. The disadvantage is every time you add a new iMessage type, you have to go into this chat socket type to let it know. So the advantage is all your serialization code is in one place. The disadvantage is all your serialization code is in one place. So I'm just going to keep it all in one place for now. I think that's, at least for now, that's the decision I'm going to go with. I might revisit that as we add some more message types. So right now, this code in here understands, this is where this part of the protocol lives, where if the message type is 0, then this is the structure of that message, that chat message. So this both identifies 0 meaning chat message, and also here's the structure of the chat message. And then I'm going to reflect that up here with this. I'm going to say this part of the code is going to say I know how to serialize chat messages to a binary stream. Unknown message type. So let's go ahead and do that. Hopefully we can get through that today. Oh, I've got 3 minutes. Doesn't look like it. So actually this is done already in our client, of course. So we've got essentially all of this here. This code is going to be essentially copied and pasted into our chat socket now. So we've got our chat message.text, and then we, instead of our output pipe, oh, actually we do have a PipelineSocket output pipe here, don't we? Just there. Binary primitives we need to pull in, and then our PipelineSocket as such. There is one other thing here that I'm not going to address today for sake of time, but be aware that send message cannot be called concurrently right now. Right now, we're doing several different things. Essentially, when you're writing to a pipeline, I haven't actually verified this, but I expect, between this get memory call and this this advance call, you can't actually have other threads talking to this pipeline, the same pipeline. So if multiple different threads call send message at the same time, which is a real possibility on the server side when you've got lots of people chatting to send out these chat messages, it's normal. It would be normal to call send message multiple times from different places. Right now, the code does not handle that. I'll just add a to do here. To do. Currently, not concurrent. Not okay. That's too clever. Currently, not thread safe. We will fix that in a little bit, but right now I'm just going to leave it as is, just to see if we can get this working today. So yeah, actually that's all we need. So I'm going to move this flush async out to here, because any message that we send is going to have to flush. So yeah, that looks great. So let's see here. Now let's actually use this in our client and our server and see how well this works. All right, so we've got so we're going to say, let's say here's our chat, and this is going to be actually like more like a chat connection, right? I might change that chat socket to chat connection. Pass in this pipeline socket, and then then we just send dot send message, and we're going to create a new chat message with the text hello server. And now all the protocol stuff is in this chat connection type, or the chat socket. And I'm just going to rename that right now because I want it to be chat connection. All right, now it's chat connection. So let's jump over to our server. And we should be able to, okay, so this one doesn't actually, oh, it does parse, right? Of course it parses. So what we don't have a way to read that out. That's fine because right now our chat connection is hard-coded how we process these things. To do, remove, hard-coded processing. Right now that's fine. We're just going to run a test, see if it works. But eventually what I'm going to do tomorrow is pull this hard-coded processing back out. We're going to hook up a channel. We're going to make this use async enumerable. It's going to be beautiful. And then this, that the console.write line will move back over to this type, to this application over here. But for now, just for today, we're going to leave it in there. We're not going to need that anymore. And our process socket now becomes, so we've got the new chat connection. We're passing in the pipeline socket. And then that handle pipeline async actually just becomes part of that pipeline socket. So then we can just await pipeline socket.main task. And actually that's it. Okay. And this all just, boom, goes away. So now our client and server are much more simple. Although the server isn't actually doing its own processing. This should work. All right, moment of truth here. Let's run this server. And let's run this client. And we'll see what happens. Here we go. Yay. So it all works. All right, so today has been like mainly refactoring. A couple bug fixes at the beginning, some refactoring. And what we've ended up with is we've started to build out this library with now more flexible messages. We can add more messages more easily. And we have this chat connection, which handles all of our actual parsing and serialization back and forth. Okay, so that I think is going to wrap us up for today. Tomorrow we'll come back. We'll probably get rid of this processing first, do the async enumerable, and then make this also thread safe because we're going to use the same kind of not reflective. What's it? Symmetric. A symmetric API. So what we're actually going to end up doing is adding a queue here for sending messages. So our messages actually get into a queue to be sent. And then our messages coming out, we're going to add a queue here. Just because that's the easiest way to do an async enumerable. All right, so that concludes today's broadcast. Thank you all for for listening in, and have a great day.